that. All right, we're going to fill out the ISN page 7, which we did notes on this yesterday. So this is just giving us the examples in our ISN. So what's this about? Well, you might remember that slope formula, m is equal to y2 minus y1 over x2 minus x1. So that's the formula that we discussed yesterday. And I talked to you about, I did a lot of highlighting where I said the y's, of course, are the second numbers in the ordered pairs or points, and the x's are the first numbers. Okay, so you want to make sure you're subtracting the y's and then the x's. Well, I think I'll stick with that highlighter. So I'm going to quick just say that I'm going to be doing the y's on top and the x's on the bottom for each set of points. And then I'm going to simplify that. That's why I gave myself a little room. So to do the y's for the mn, you do 4 minus 3 on top. Subtract the x's, 4 minus negative 1. 4 minus 3, of course, is 1. And 4 minus negative 1 would be 4 plus 1, which is 5. For the second pair of points, R and S, starting with the y's, 2 minus 1. On the bottom, subtract the x's, negative 2 minus 3. That simplifies to 1 over negative 5, or just negative 1/5. Now, the relationship we talked about, let's remember what we said. For parallel lines, the slopes are the same. For perpendicular lines, slopes are negative reciprocals, which means they have the opposite sign and they're flipped. Now, if it's neither, it's just that it's not one or the other of those. All right, so what do we got here? We got 1/5 and a negative 1/5. The signs are opposite, but they're not flipped. The signs aren't the same, so they're not parallel because they're not equal slopes. But the signs are opposite, but that's not enough for it to be perpendicular. So this would be neither. And the reason why is the slopes are not equal. And they're not negative reciprocals. You can abbreviate negative NEG and recips for reciprocals for our notes here. Okay, so now we're going to do another pair of points, and we're going to figure that out the same thing. So the y's go first. They're the second numbers in the ordered pairs. If you like to color, I'm just trying to be consistent with what I talked about yesterday. If you don't need to, that's more power to you. Okay, so we got the n, m, or mn. We want to find the slope. So we start with negative 7 and subtract negative 3. Negative 7 minus negative 3 over negative 2 minus 0. Negative 7 minus negative 3 would be negative 7 plus 3, which is negative 4. Negative 2 minus 0 would be negative 2, and I didn't really give us very much room to write this all out. Negative 4 divided by negative 2 would be positive 2. Okay, for the slope of RS, start with the y's again, negative 3 minus 1. The x is 0 minus 2. Negative 3 minus 1 is negative 4. 0 minus 2 is negative 2, and when you divide negative 4 by negative 2 again, you get positive 2. So, slopes are the same number. So these lines that would pass through those points would be parallel. And that why is because they have the same slope, or the slopes are equal. Right? Okay, next we have some examples of graphing some lines that have certain conditions. It says graph the line that satisfies each condition. We want it to have a slope of 3. So m equals 3. You think of it as a fraction, 3 over 1, which means up 3, right 1. But where do you start? Well, this isn't giving us necessarily an x-intercept or y. It's giving us a point that we need to find. And it's called 0, 1. So 0, 1, you don't go right or left. You go up to 1 on the y-axis. So that's where point A is. And then it says to use the slope of 3. So we go to the point A, and we climb 1, 2, 3 up and right 1. We could only do that one time on our graph. So we can go back to the point A and reverse the slope. So instead of up 3, right 1, we're going to go down 1, 2, 3 and left 1. And do that again. Down 1, 2, 3, left 1. So we've got enough points. We graphed our line. We don't want a stubby little line, so we're going to make it extend through the grid, the coordinate plane. All right, second one has a slope of -3/2. M is what we use for slope in the equations. I'm just writing what that means to do. -3/2 would mean down 3 and right 2. Okay, if it's passing through this point, that's where we're going to start, at R, the point -4, 5. So to plot that point, we go left 4, up 5. There's where point R is. From that point, we're going to do the slope of -3 over 2, which is down 1, 2, 3, and right 2. Could do it again. Down 1, 2, 3, right 2. We're hitting the y-axis at that spot. Do it one more time. 1, 2, 3, right 2. Okay, and then make a line through your points. Two more examples. Number 3 says we're passing through the point y equals 3, 0. So that's where we're going to start. Parallel to a line DJ, which is not even graphed here. Sorry about this thing. I don't know how it got there, but whose slope is -2. Now the slope -2 would be -2 over 1, which is going to mean down 2, right 1. But I got to start at 3, 0, which is right 3, and then stay there. Why am I doing the slope -2 over 1? Because parallel lines have the same slope. Okay, so if this line has a slope of -2, then the line parallel would have the same slope. Okay, so that's why I'm using -2 over 1. So I'm going down 2, right 1, down 2, right 1. I can go back to my point Y and do up 2, left 1. And then just graph the line. All right, next one. Now I want to do a line that passes through the point 0, -2, which is on the y-axis here. That's where T is. But it needs to be perpendicular to a line whose slope is 3. Well, if the slope of this line is 3, the perpendicular line's slope is not going to be 3. It would be, a perpendicular line slope is not going to be 3. It will be, how do you flip over a 3? it'll be 1 over 3. And then you also have to change the sign. So it's going to be negative 1/3. So that's going to be down 1, right 3. So from here, we're going to go down 1, right 1, 2, 3. I can't do that again. So I just think about it in reverse. Go back to T, reverse down 1, right 3 to up 1, left 1, 2, 3. And I can only do a couple points, or one more point, so I'm going to go ahead and sketch my line. All right, that's it for the ISN. We will be on Monday starting to write equations of lines. What we're going to do now, I'd like you to find, I gave you the first day, let's see, after 3/5, it would have been, I think, Friday. I gave you 2 worksheets, and we never did one of them. It says on it, slope practice, I believe. Yeah. It's a single sheet, not a stapled one. It says slope practice. All right, so I'm going to just do an example of the types of problems that you need to work on in here. You may wish to write down the formula, I guess, at the top of your paper for finding slope. Remember the y's, it's a change in y over the change in x, vertical change over horizontal change. So we're going to be working with the points and doing the y's first, just like we were talking about in the ISN. All right, so when we do this, do the y's on top, x is on the bottom. 4 minus 0 would be on top for this one. Negative 3, minus 3 on the bottom. Bless you. 4 minus 0 is 4. Negative 3 minus 3 is negative 6. And then we need to reduce. And I know some of you were already working on this. You may have some of it done, but we're working on finishing it today. Negative 2/3 would be the slope for this one. We'll do one more of these. Oh, actually, I'm going to go to a really icky one in here. If someone worked on it, yes, number 6 is the one I'm referring to. 5 minus 5 and 1 minus negative 4. Well, 5 minus 5 gives us 0. So on the bottom we have 5, but when we divide, we get 0. That one has a slope of 0, which would mean it's a horizontal line that passes through those 2 points. Let's go to 6 because it's gross. I'll try to help you out with your calculator. I have no idea. I'm not going to test you or put a bunch of fractions on your tests, but they do occur in the world, so we've got to deal with them sometimes. So we subtract our y's. We would be starting with 3/4 and negative 1/5. And then our x's on the bottom. And they are fractions. So I'm going to show you how to have your calculator help you out if you're dealing with fractions. So we're going to do 3/4 minus negative 1/5. And on the bottom, we're going to do 2/3 minus negative 1. Okay, well, you have to get common denominators when you're doing fractions. So you would have to multiply this fraction by 5/5 and this one by 4/4 if you were going to do it without your calculator. Since a lot of us are fraction phobic, I think I'm going to just type it on the calculator today, right now, and do it. And I can show the way to do it without that, but I'll do this first. Okay, so was it, I just forgot my fractions. Was it 3/4? 3 divided by 4. That's what that means. And then we were subtracting what? Negative 1/5. Negative 1 divided by 5. Now I want to do the top separate from the bottom, just like I've been doing all along. So I'm going to hit enter, and I'm going to get a decimal, and then I'm going to tell the calculator to put it back to a fraction by doing the following. And this is how you can deal with fractions. You may want to be punching these numbers right now because you're not always going to get off the hook with fractions. You're going to have to deal with them, and especially when you go into Algebra 2. So we're going to hit Math, enter, enter, and you get 19 over 20. Remember I said we'd have to get a common denominator of 20? You would have done this. Multiply top and bottom by 5. That would have given me 15 over 20. This would be plus, because you subtract a negative. You would have multiplied this one by 4 over 4, and that would have given you 4/20. Now you see where the 19/20 comes from? 15 plus 4, 19/20. On the bottom, you got 2/3 minus negative 1. So here's how you can type it. 2 divided by 3 minus negative 1. Enter. Hit your math button. Get it back to a fraction by hitting enter, enter. And it says 5/3. Well, now, if you didn't know a lot about fractions, you might not know what to do. What do you do when you divide by a fraction? Anybody remember? You change division to multiply by the reciprocal. And this is something you're supposed to know before you ever got to this course. 19/20 times 3/5. Bless you. Okay, you can actually type that on the calculator, or you can do 3 times 19, which is 57, and 20 times 5 is 100. That would be the slope of that line. I'm glad I'm not graphing that one, because I'd have to go up 57, right 100 to get to the next nice point, and that would be crazy on a graph. All right, no more of those really horrible ones. So you're going to go back and finish up these. Right now, please stay with me and go to number 7. There are lots of real-life applications of constant rate of change. Slope is a constant rate of change because it's going up the same amount every time. And that's why you figure out the slope. So your line will be nice and straight. What is the rate of change for this? Well, since it does start at 0, 0, I can go down there. And I can say, well, how do I get to the next nice point? Well, I go up how much? Yep, 40 feet. So that's got a label. You're going up 40 feet, and then you're going right for how long? 5 minutes. So these need labels. Now, you can simplify these. So you divide 40 by 5, and that gives you 8 feet per 1 minute, or just minutes. You don't have to write the 1. But you have to have a full label. Now, does it keep doing that? Yeah, it's going up 40, right, 5 more minutes, up 40, right, 5 more minutes. That's why it's called a constant rate of change, and it forms a line, linear. It has to be consistently the same, else it's not going to be linear. You'll find out in Algebra 2 that there are other changing rates of change when you do parabolas. But here we go with this one, number 8. Now we're talking about dollars. Well, that's going to be how much it costs for a book. So we're going up 15, right 3. So that's $15 for 3 books. I don't know why I wrote it so slanty, but if you divide 15 by 3, that's telling you that it costs $5 per book. Dollars. I don't know what's wrong with my dollar sign there. Right. That's why you do that section. So you'll want to have labels on 9 and 10. Okay. When you get to 11, you're simply counting your slopes, and you want to make sure you go left to right on your graphs. The slope's moving up 1 right, 1 up, 1 right, 1 up, 1 right, 1. So the slope's 1 over 1, and then you simplify that to 1. Okay. All right, let's look at any other kinds on here. Let's these are going to be negative slope because they're down. Down 2, right 2. Negative 2 over 2. And that's a negative 1 slope. That's important for us to be able to count these. We're going to be writing equations of lines from graphs and from points. Okay, please look at 15 with me. Remember that slope is the change in y over the change in the x's. Nice to think of it that way because what's the change in the y's? If you look at these numbers, how are they changing? Are they going up 3, down 3, up 3, right? Up 3. So that's the top part. 3 over. So my slope's going to be 3 over something. Then I look over here at the x's. How are the x's changing? They're going up by 1. Up 1. So that's 3 over 1, which is 3. What? All right. Okay, slope of 3 for that one. That's how you can do these problems. Or, let me show you another way. You can take any pair of points here and do the slope formula. You would take the second one minus the first one. So you could have done 3 minus 0 over 1 minus 0. And you would have had the slope. So you can do it that way using the formula. So if you choose to do it by the formula, I think it's easier just to look at what's happening. If you go from 5 to 4, are you going up or down? Yeah, so that's down 1. This is down 1, so the top number is negative 1. And how are these moving, though? Well, maybe you don't see from negative 2 to 2 is adding on 4, but it is to go to here, so at least you got it there. So the change is negative 1 over 4. That's your slope. If that's not working for you, you can take any pair of points and do the formula. 2, 4, and 6, 3. You would have subtracted the y's, 3 minus 4, subtracted the x's, 6 minus 2, and there you go with the negative 1/4. Any questions about how to do it with the grids? All right, so then you've got a couple more to do. And then I want you to flip it over for a second. Let me talk to you about the duck that steals. And I'm just showing you how to get the worksheet done. And then I can stop recording and let you work and help you. All right, what do you call a duck that steals? All right, I don't know, but we'll find out. Find the slope of the line, reduce your fraction if necessary, and cross out the answer below. So, for example, to go from A to B, you are going left to right. So you start at A, you go to B, you count vertically 1, 2, 3, 4, up, and right 3, which is a positive slope. Remember, slope man. His left eyebrow's uphill, that's positive slope. His right eye downhill, negative slope. His nose undefined for vertical, and his mouth is flat, 0. His dimple says slope is 0. So this should have been positive slope, and it was 4/3. So please write your slopes next to your pictures. Then you can go to the bottom of the page, find 4/3, and then I would cross out that box. You might want to make it so you can still see it in case you make a mistake. Let's do one that's going downhill. So number 2, you're going from A to B again. How do you climb? Down 1, 2, 3, 4, 5, 6, and right 3. So that's negative 6 over 3. And that reduces to negative 2. So I go look for negative 2 in the puzzle, and I cross out that. When you finish, you have to do all the problems first. What's left goes in the boxes below to get you your answer. Any questions about how to complete this? All right, we'll let you work on it quietly, please. And then if you have any questions about yesterday's homework, you can ask me that as well. Does anybody know they have one right away? Right, you do? Okay. Might as well include that in my recording then. So we did all this about parallel, perpendicular, or neither yesterday. What number, hon? Oh, on the way back. Okay. On the homework, of course. All right. Okay, good idea. Yep. The coordinates of the vertices of a right triangle. Okay, so we know that this is a right triangle, which means two of the sides form a what? Yep, 90-degree angle, which means they will have some perpendicular slopes, meaning the slopes are going to be negative reciprocals. That's what we're looking for. You want to look for some negative reciprocal slopes. So it says if you know the coordinates of the corners of that thing, and I don't know which one's which, and I'm not plotting it, I'm just going to tell you what we could do. We would want to find the slope of the segments that make these lines. So if the slope of PQ, I would do -1 minus 1 over 1 minus 5. That would be -2 over -4, which reduces to 1/2. Next, I would do the slope of QR, and I would take my y's, 5 and -1, and subtract them, 5 minus -1, and -2 minus 1. That's going to give me 6 over -3, which reduces to -2. All right, now I'm going to do one more slope, E and R. The y's are 5 and 1, so subtract. -2 and 5 are the x's. Subtract -2 and 5. 5 minus 1 is 4. -2 minus 5 would be -7. So guess what's the hypotenuse? All right, you see how these two have slopes that are negative reciprocals? These would be the ones that form the perpendicular sides, or right. It's going to be a right angle between them. That means this one's the hypotenuse. So PR is the hypotenuse. And then then that's all it asks. The other two are the legs. Yes. Pardon? 13. On a map, okay, a highway on a map. This is like the airplane one I did in the notes. Right? Okay, thank you. Rise is 15 feet. So rising would be going up. So that would be the top of the slope. Okay. Now it says horizontal. That's going right or left. So that's going to be the bottom of the slope. And then you just need to reduce. So the slope of the ramp is 15 over 100. Now ramps can't be very steep. But you can divide by 3 top and bottom. So that's 3 to 20. Okay, so every 3 feet vertically, it's 20 feet horizontally. So you see how that wouldn't be very steep, would it? But that's what it's got to be when you're driving. You can't go up really, really steep inclines. And you can't have ramps that are too steep for handicaps either. Handicap ramps. Let me have another one in the 3-3 packet. No? So like 15, all we want to do is try to find this. We want to find the slope between the lines. The one that doesn't have a slope that's opposite reciprocals with the other is the hypotenuse.